Jessica.
Oh, yeah, all panelists are here.
Hi, David. Hi, Lucina.
Hi, how are you?
Hi, Eric. I'm doing great. How are you guys doing?
Very
Hey,
well.
Gary.
Hmm.
Robert, just as a point here, we're not seeing anybody outside of the
Us.
direct team.
Yeah, it's
you're
only
you're only going to
presenters.
see the panelists. Currently, there are 56 people in the webinar.
Okay, there's other people on, but we can't see them. I see.
Yeah,
Well, that's good news. I thought I was worried for a second.
no, they can see you and hear you. They just their names are hidden.
Okay.
We'll wait a moment more and then we'll get started here. Thank you for joining, everybody. This is Dave Zero. I'll be your host today. And as I said, we're going to give it another moment. We're expecting perhaps 100 or so, and look forward to your participation. So we'll come back in roughly a minute. Okay, let's go ahead and get this kicked off. Again, I'm Dave Zero. Thank you for joining us today. I think we've got a very strong technical presentation for you. This is, again, first of a four-part series, and it's going to be focused in on defining the best available technology to deal with paper dust, particularly in tissue, on paper machines and converted assets. And again, because this is a typical disclosure, we want to make sure everybody understands that we will run this with TAPI antitrust policy. I'm sure everybody's familiar with this, so I will not read it, but I just want to make sure that everybody's aware that is the intent. Okay, so again, why are we doing this? Why focus on dust? I think one of the key issues we always focus on is that there's a lot of challenges in pulp and paper, particularly in tissue, and dust is one of those key areas. There's a good article by Dr. Clooney back in January 20, just last month, in the Pulp and Paper Canada, and this shows 2023 recorded incidents. And while it shows fires, as you look at fires improving over the years, explosions going down, definitely good strong trends, not only US, but in Canada, internationally. The important thing is that probably 90% of fires do not get reported. I'll let that sink in for a moment. So there's a lot of things that typically the only time that they do get recorded is when the local police department, local fire department has to come in. And that's what makes these, yes, we're seeing better trends, but there's still way too many. And, throughout the US, now not just in pulp and paper, but there's been 28 explosions, 25 injuries, and 6 fatalities. Again, this is not just pulp and paper, but all industries. So it really helps hopefully set the tone. Why are we even dealing with this? Jessica?
So I'd like to welcome everybody to this webinar, and a special thank you to our organizers and presenters today. So this is a presentation series of webinars that are part of the TAPI Tissue Division. So my co-chair and I, Gary Furman, welcome you. We look forward to seeing you at some upcoming events, and also options to participate in the TAPI tissue subcommittees, including the Tissue Dust Committee, which is very topical for this webinar. So thank you to the leadership, Alfredo, Jeff, and Bud, for that subcommittee, and the Yankee Dryer Safety Committee. So some upcoming opportunities for you to interact with the different courses. TAPICon, of course, coming up in May. That'll be in Minneapolis this year. A lot of great tissue-based subjects. If you want to come on site for TAPICon, is also an option to add on the 101 course. So you can, when you do your registration, you can actually just click a box to sign up also at the same time for this introductory course. And then later in May in Neenah, there'll be the 201. Also a dust mitigation online course offered by TAPISAFE, and continuing Yankee Dryer Safety and Dust Mitigation subcommittees. And you can contact our TAPI staff, Robert Davies, with the email that's listed below. So thank you. I turn it back over to the presenters for a great webinar.
Well, thank you, Jessica. And again, this is going to be the first of 4. The first webinar is going to be what I'll call a foundational one that introduces the effective use of chemicals to not only help capture dust, but surprisingly leads to better handfeel. So we're going to have a good hour-long discussion relative to that. Second seminar coming up in April is going to be dealing with a laser to measure dust generated off a paper machine or converting asset. Third in the series will be a Yankee dryer coating package and Dr. Blades that will be hosted by Jeff Peters, and then a review of enzymes that will be reviewed by Bud Chase. Further, want to let you know that you can, for those that attend, can earn a 1-hour credit towards a professional engineer's continuing education. If interested, just email Robert. And also for questions, please post those in the Q&A box, and we'll address those at the end of the session here. Okay, so let me present our 2 presenters today. First is Lucina Halaska. And she's a process application expert at Camara. She's worked closely with Camara Cell and R&D groups to facilitate developing new products, and she specializes in wetting chemistry. She's had a progressive number of positions. She started her career with American Cyanamide, and in 2006 joined Camara. Lucina also teaches the TAPI Tissue 101 course since back in 2011. I'll also introduce Eric at this time. Eric's the area manager for MTech, and I think most of us are familiar with their TSA equipment. He is focused in on electronics for paper, nonwovens, textile customers, both in Canada and the USA. And he's become the sales manager for a number of countries, including North America, Germany, Switzerland, and Greece. And I'm the session chair. Been around the block, worked at Procter & Gamble, Georgia Pacific, now with Pomac as the vice president of R&D. And I've got a lot of experience in manufacturing, troubleshooting, R&D, QC, finance, and project management. And we have a rock star with us today. Lucina, we'd like to again congratulate you for winning TAPI's Tissue Technical Award. This was a surprise, I'm sure, that she wasn't expecting. We'd given this to her, but it's great to recognize the huge efforts and contributions that Lucina has made. As you read through this, a number of TAPI conferences, Tissue World Magazine, paper recycling, 4 patents, line panel conferences, instructors, as you heard, for Tissue 101. She's been an instructor at Western Michigan and an instructor at Lake State TAPI tissue seminars. And she played a major role in developing dust analysis methodology, which we'll hear about later today. And again, a warm welcome, Lucina. Thank you for all your contributions. And I'll turn this over now to Lucina.
Thank you so much, Dave, for this great introduction. And welcome everybody at today's webinar. And during today's webinar, I'm going to present how the chemistry used to contain dust on tissue paper machine affects tissue Handfeel. Next. As you all well know, in the recent years, the dusting during tissue production is significantly increased. And this is the result of customer desire to use softer tissue. And tissue producers, to increase tissue softness, they use higher content of hardwood fiber, especially eucalyptus fiber that is shorter and weaker than softwood fiber, and that increase the tendency of the sheet to dusting. The most dust is generated during the creping process. And to increase the tissue softness, tissue producers reduce the sheet moisture during this process to as low as 2.5 to 3.5%. And at this low sheet moisture, the sheet is exploded to a higher degree and more dust is generated. Also, many tissue producers rely on using just fiber refining to develop dry tensile in the sheet. And excessive refining can lead to formation of fines in the system, which again contribute to the increased dusting. And finally, the use of weak recycled fiber, it's also a major contributor to increased dusting. Reducing dusting while maintaining or increasing the softness of the tissue, it's a major goal of tissue producers these days. Reducing dusting could have many benefits. First of all, reducing dusting in the final product will increase the quality of this product. Also, reducing dust in the air will increase the health and safety of workers in paper mills and reduce fire risk. Reduced dust will also improve tissue machine and converting machines runnability and overall increase the production efficiency. Next. The most effective way to reduce the dust is by the application of dry strength resins and partial reduction of fiber refining. Partial reduction of fiber refining will lead to less fines formation in this wet-end system, and dry strength resins can substitute this refining in developing additional hydrogen bonds between fibers and developing dry tensile in the sheet. This type of approach allows to maintain dry strength targets, maintain or increase the softness of tissue, and achieve higher bulk and stretch of the sheet. There are additional benefits of this approach, such as ability to increase hardwood content in the furnish, increased fiber retention and drainage, reduce load of fiber recovery system, and also reduce stickies and pitch formation and deposition. There are other means of reduction of dust, such as use of functional promoters. Functional promoters could be mild retention aid that increase this retention aids or functional promoters will reduce the load of fines in the wet end system. We can also use softeners to reduce the dust. By using softeners, we can slightly increase moisture during the creping process or reduce the hardwood content and keep target softness of the tissue. Next one. It's pretty difficult to measure the dust generated on tissue machine or dust on the surface of the tissue. Chemira developed the method that analyzes dust content on the surface of the tissue. This method utilized ChemView sheet structure and dust analyzer. This instrument is image-based tool equipped with camera, lenses, and LED light, and it's in the form of this big flashlight that you can see on the picture. And this big and the instrument is connected to the computer that contain specialized software for sheet structure and dust measurement. The ChemView method is pretty fast and reliable in analyzing sheet structure and analyzing dust on the surface of the sheet. Next one. According to this method, the dust from the surface of the sheet, it's transferred on the black felt using well-defined method as the sheet is under light pressure. The instrument takes a picture of the felt before and after dust transfer and subtracts the felt background. The results are expressed in a number of particles per centimeter square of measured area. And the instrument categorizes the dust according to the size. Fibers are not circular particles that are longer than 60 microns. Fines could be circular or elongated particles that have a size between 15 and 16 microns, and starch and ash are particles that are shorter than 15 microns. We can use two types of dry strength resins for dust control. One is based on glyoxylated polyacromate, GPEM, and another type is based on solution polyacromate. GPEM resin have cationic charge. They developed not only dry strength, but also wet strength. And the resins that develop ultra-temporary wet strength are used for production of bath tissue, while the resins that develop less temporary wet strength are used for production of napkin, facial, and towel grades. Solution polyachromates could have cationic, anionic, or amphoteric charge. They only develop dry strength. They do not develop wet strength. And cationic products are used mostly for production of bath tissue, while anionic are used for production of towel, and amphoteric could be used for production of any tissue grade. Next one. I'm going to share with you few case studies, and most of these case studies will contain, we include the results from the measurement of tissue dust done with ChemView sheet structure and dust analyzer, and results of Handfeel softness measured with tissue softener analyzer produced by MTech. In this first case studies, The first case study shows the application of solution polyacromide dry strength resin during the production of at-home premium bath tissue made with virgin fiber on light dry crepe machine that was equipped with 2 layers head bags. And this machine experienced excessive dusting due to the high content of fines in hardwood pulp, and also due to the fact that they use high content of hardwood in the Yankee layer of the head bags. And as you can see on this chart, the application of 0.5 kilograms per metric ton of solution polyacromide and the reduction of fiber refining by 64% were able to reduce the dust by up to 82%, which is very significant. At the same time, the Handfeel softness was maintained, and also dry strength targets were maintained. Next one. The second case study also shows the application of solution polyacromide during the production of at-home premium bath tissue made on TAT machine equipped with 3 layers head bags. And again, this machine experienced extensive dusting due to high content of hardwood in the Yankee head bags layer, and also due to the low sheet moisture during the creping process. And as you can see on this chart, the application of 0.3 kilograms per metric ton of solution polyacromide and the reduction of refining power by 8% allowed to reduce the dust by up to 55%. The main goal of this trial was dust reduction, not only dust reduction, but also the softness increase. And Handfeel softness, as measured by TSA, tissue softness analyzer, was increased during this trial by 2.5%. However, the human panel softness results did not show higher softness of tissue produced during this trial. So further optimization of this application is needed. Next one. The third case study shows the application of glyoxylated polyacromide during the production of at-home premium bath tissue made on structured tissue machine. It was NTT machine that was equipped with 3 layers head bags. And this machine experienced excessive dusting due to, again, high content of fines in hardwood pulp, layering of hardwood on the Yankee and air side of the head bags, and use of softeners and enzyme at the wet end. And by increasing the dose of GPEM resin from 0.5 to 2.5 pounds per ton, and reduction of fiber refining, we're able to reduce the dust by up to 84%. That was a really significant reduction. And as you can see on the chart, at 1 pound per ton and 1.5 pounds per ton, the tissue softness was not affected by this approach. But at 2 pounds per ton and 2.5 pounds per ton of GPEM resin, the dry tensile was increased, and the softness of the sheet was slightly decreased. Besides substantial, could you go back? besides substantial reduction of the dust, during this trial, we also achieved increased machine speed due to better retention, better drainage, better retention, higher stretch. Next one. And the fourth case studies shows the reduction of dust in premium buff tissue. And in this case, the goal of this trial was to produce strong and soft tissue that generates minimum dust. During the trial, we increased GPEM resin from 5 pounds per ton to 7 pounds per ton. And we were able to reduce dust by this application by 68%. I don't have softness data for hand sheets for the sheets that were made during this trial. However, based on the increased dry tensile at 7 pounds per ton of GPEM, I will assume that the softness was also reduced. And this chart shows not only the total dust shown by blue bars, but also shows the fiber count, fines count, and starch and ash count. Next one. The objective of fifth case studies was to reduce the dust in brown napkin, and excessive dust in this brown napkin caused the problems during the converting process. So first, during the trial, we decreased the refining during the brown napkin production, and this decreased refining resulted in 60% dust reduction. Then we apply 4 pounds per ton of GPEM resin under a low refining condition. And under this condition, the dust in the sheet was reduced by 76%. Application of GPEM resin increased the dry tensile, which allowed the mill to reduce the basis weight and crepe ratio. And overall, we were able to also increase first pass retention, drainage, and increase machine speed. Next one. The 6 case studies showed dust reduction in towel. This towel was made on structured tissue machine equipped with 3 layers head bags. And the towel was made with a virgin fiber. In this case, we applied GPEM resin at the range from 1 to 8.7 pounds per ton. And this application allowed to reduce the dust in towel by 30 to 70%. Next one. We can reduce dust by increasing fines and fiber retention in the sheet. And this case study shows the application of 1.5 pounds per ton of amphoteric functional promoter during the production of a brown napkin made with recycled fiber. And the application of this functional promoter allowed to increase the first pass retention from 30 to 50%. At the same time, we were able to increase machine speed by 2.1%. We're able to eliminate GPEM resin and reduce refining while maintaining target strength targets. Also, the downtime of the machine for removal of stickies from the wire and felt were reduced by 70%. Where we did not measure the dust content on the sheet during this trial. However, we observed significant reduction of the dust at the Yankee dryer during the creping process. Next one. The tissue dusting could be decreased by reducing the eucalyptus fiber content and substituting this decrease with the application of softeners to maintain tissue handfeel. In the lab study, we demonstrated the ability to maintain tissue softness by this approach. We have made two sets of hand sheets. One was made with 70% eucalyptus and 30% softwood, and another hand sheets were made with only 50% eucalyptus and 50% softwood. The hand sheets made with 50% eucalyptus and 50% softwood were sprayed as they were still wet with 3 types of softeners to mimic spray on application on the tissue machine. Next one. And this chart shows that TS7 achieved with hand sheets made during this lab study. TS7 is a result of tissue softener analyzer measurement and indicates real softness of tissue. The higher number indicates lower softness. As expected, the hand sheets that were made with 50% eucalyptus and 50% softwood fiber blend, and which were not treated with softeners, had the highest TS7, so they had the worst softness. But the same type of hand sheets made with 50-50 eucalyptus softwood blend sprayed with A, B, and C softener had this TS7 value decreased by 15 to 35%. And this value was equal or slightly lower for some cases than TS7 value obtained with the hand sheets made with 70-30% eucalyptus softwood fiber blend. Next one. Spraying the hand sheets with 3 different softeners also increased the sheet bulk by 2 to 4%, which again contributed to increased softness of the hand sheets. Next one. And as expected, application of softeners reduced the dry tensor of the hand sheets by 4 to 10%. And at lower dry tensor, the softness of the hand sheets was also increased. Next one. So in summary, we can say that application of dry strength resins combined with the fiber refining reduction or increase of hardwood content proved to be very effective in reducing tissue dust while maintaining or increasing tissue softness. There are other chemical applications. They may reduce dust, such as application of functional promoters or application of softeners while reducing fiber content or increasing moisture during the creping process. And this is all what I have for you today.
Well, thank you, Luciana. That was very enlightening. I think that as we go through this and learn more about the techniques that you used, I think will be quite beneficial for all the manufacturers out there. And again, we'll ask you to put any questions you have in the Q&A box. We will cover these later. And without further ado, Eric, who we've introduced, I'll turn that over to you, Eric.
All right. Thanks, Dave. Also, thank you all of the TABI committee here for the possibility to introduce the TSA, the Tissue Softness Analyzer. Lucina already a little bit introduced or spoke a little bit about the device, and now it's my pleasure to introduce the technical details of the instrument in detail. We have spoken the last few minutes already about hand feel, softness, a lot of words which are important parameters to analyze in the tissue paper production. And due to the fact that the softness is getting more and more important for products over the last years, it's important to measure things. Yeah, as you have heard, the dust mitigation, dust can be kept under control by the use of chemicals and enzymes. And by the way, we also do have an online zeta potential analyzer to see the interaction between chemicals and fibers online for trials and also for current production. But today our topic is of course the TSA, because all of these chemicals do have an influence to the hand feel, to the haptic and softness of tissue paper products. And with the TSA, we have a fast and reliable objective measurement method. And by the way, the instrument you see here on the picture is the latest version of the instrument. Maybe a few of you are aware of the current model, and this is the successor, the new TSA2. Next slide, please. To explain for how the TSA is working, I start to explain how the human hand feel, or how a hand feel in general works with the human hand. And this is important to understand how the device is working, because the device's way to operate is 100% adapted to how the human hand is working. Next slide, please. If you take the term hand feel or touch, yeah, this is based on three main parameters. It's the smoothness on the surface. For example, smoothness is defined by the surface structure of the product. You can compare a smooth product maybe with a base tissue, and a rough product with a embossed material. Then we have the second term, or the second parameter, is the real felt fiber softness. This is what Lucina already mentioned. This is the little fiber hairs which are influenced by chemicals, refining, whatsoever. And then there is the stiffness or flexibility of the material. And these three parameters combined result in the hand feel or touch. Next slide, please. And what happens is the hand is moving over the surface, and independent on how the material is tested, this process still will remain the same. So as you all know, the material could be placed on a solid surface. You can take the material in both hands. You can test it from one side, or you can test it from both sides, or crumble it in your hand. But what happens when the hand is touching the material will every time remain the same. Next slide, please. What happens is that when the human hand is moving over a tissue paper product, or textile, or nonwoven, or whatsoever, is the papillary lines in our fingertips, in combination with the sample surface, do generate vibrations. And these vibrations will be received by special sensors in our fingertips. And these sensors in our fingertips are related to the previous mentioned three parameters: roughness, softness, and stiffness. And now you could say, okay, for what do you need a device? Yeah, our hand can do this all by itself. It's unfortunately not that easy, because even though the sensors in our fingertips do receive the signals individually, our brain automatically combines them to an overall haptic impression. And therefore, the human hand cannot satisfyingly distinguish within these parameters. And that's one of the main issues. Next slide, please. Also, the problem is that if the human hand is touching something, the impression, the hand feel, is influenced by testing procedure, as mentioned before. Also, the personal mood, the influences from ethnical or environment, or also personal or market-specific preferences. And that's what makes testing with the human hand makes every time very difficult. Next slide, please. And therefore, we have developed the MTech TSA. And with the TSA, we can individually and objectively measure the three mentioned parameters: smoothness, softness, and stiffness. And this is very fast, approximately 90 seconds in a two-step analysis. And how does it work? Next slide. The sample is cut out in a 100 square centimeter round circle sample size, and then it's placed into the TSA's measuring cell. And then we apply a defined load of 100 millinewton to the sample. And after this, the rotor head with the blades start to rotate over the surface. And by this, we measure two significant vibrations. The first vibration is the vibration of the sample itself when the rotor blades start to rotate over the surface. And a lower vibration results in a smoother material, and a more intense vibration results in a rougher material. The second vibration we do analyze, or the second sound, how you want to call it, is the vibration of the blades themselves. And this gives us the information about the softness of the actual fiber material. The less the blades vibrate, more softer is the fiber material. The more intense the blades do vibrate, the harder is the fiber material. Next slide, please. And this is what you can see here. And now we see maybe one or two familiar terms. The first term is the so-called TS750 peak or value. It's the first peak on this graph. On the x-axis, you see the frequency in hertz, and on the epsilon axis, you see the intensity of the vibration. And the TS750 value gives the information about roughness or smoothness of the material. More higher the peak, more rougher is the material. The lower this peak, more smoother is the material. The second peak is the one Lucina has mentioned before. This is the so-called TS7 peak, which gives the information about the actual real felt fiber softness of the material. And it's the same deal. More higher the peak is, less soft is the material. The lower the peak is, more soft is the material. Next slide, please. And after the rotation movement has been done, we also do perform a deformation measurement, which means we increase the load from 100 to 600 millinewtons to the sample in 2 cycles. And by this, we also additionally receive the information about stiffness, but also elasticity and plasticity. But stiffness is the most important one here. Next slide, please. And if you now we have all the 3 parameters combined together, and by this combination of the individual measured values, TS750 for smoothness, TS7 for softness, and D for stiffness or displacement, combined this by special algorithms with the help of the TSA, we can calculate an overall Handfeel value. It's a number on a scale, like Lucina has shown before. And this scale must be used with the correct, or must be created by the correct algorithm. And this depends on the application of the product, for example, base tissue, toilet paper, kitchen towel, whatsoever, but also depending on the region where the product should be sold. Next slide, please. As you can imagine, the TSA has a very big variation how it can be used. For example, as an incoming control tool for research and development, how Lucina has done it, product optimization, process optimization, quality assurance, but also for benchmarking tests to look how your product is working against competitors, or also for complaint management if customers do complain about your product. Next slide, please. I hope I have kept in time. According to my clock, there is about roughly 1 minute left for my presentation. So thank you very much for giving me the opportunity to present the TSA in short here. And I'm looking forward to hear questions from your side. Thank you very much.
Thank you, Eric. Very enlightening. And Lucina, thank you as well. So let's open this up to questions from the audience.
Yeah, and I answer on the chat a few questions. One was if the ChemView was available for purchase. So it's not Chemira, it's using ChemView as a support tool. We're not in the business of selling instruments. We are in business of selling chemicals. Another was which algorithm was used in TSA measurement, presented in my webinar, and we used the second algorithm, in this measurement where TS7 is dominated value. And one was why the tissue producers would like to increase the softwood content in the furnish, and the prices of softwood and hardwood in recent years varied a lot, and it was a moment a few years ago that the softwood actually was less expensive than hardwood. And during that time, we conducted these lab studies when we showed the ability to reduce the hardwood and apply the softeners and keep a similar softness than the tissue that was made with higher content of hardwood. And at the same time, reduction of hardwood may decrease the dust content in the sheet. Another question was, is this webinar, it's going to be, the slides are going to be available for participants? And Dave, are they going to be available? Can you make them available?
I'm pretty sure, Robert, can you respond to that?
Mm-hmm.
Yes, they will be available. It will be available within the coming week.
Okay. So that's all questions that I saw. Let me see if I see any more question. Okay, yeah, I see. With the addition, I'm going to read this one. With the addition of GPEM and reduction in refining, did you characterize the fiber distribution post-refining between two conditions without GPEM and with GPEM? We did not. We didn't analyze the fines content and fiber content, so we did not do that. Does the Handfeel work on base sheet parent roll, or it's strictly for finished products? Handfeel works on both type of products, on parent rolls and on finished products. Have you seen softness changes correlated to changing eucalyptus for another hardwood source, such as aspen fiber? No, personally, I don't have this experience. I think eucalyptus is one of the softest hardwood fiber, but I didn't run the trials when different hardwood fibers were compared to each other. Let me see if there are any more. Can you comment on the mechanism by which the reduction in refining on softwood bottom layer can have impact on dust on the Yankee side? You know, I would believe that as the sheet it's exploded during the creping process, you're not only getting the fines released from the top Yankee layer, but you're getting the fines released from the whole sheet. So I would think that reduction of refining of softwood will definitely minimize the amount of fines in the whole sheet, and that will contribute to the reduction of dusting. What is the difference between GPEM resin and solution polyacromide? Solution polyacromide does not use glyox. It's not a reactive polymer. It's usually copolymer of some anionic, cationic monomers and acrylonitrile, where GPEM resin, it's a reactive polymer. It's made by reacting copolymer of DADMAC and acrylamide with glyoxal. And this polymer still reacts after it's being applied on the sheet, and and undergoes further cross-linking reaction as the sheet is dried. Solution polyacromide doesn't develop any wet tensile, where GPEM resin develops wet tensile because it covers the fiber bonds and prevents water from penetration with fiber bonds and breaking the bonding between, swelling the fiber and breaking the bonds between fiber. And so I'm not sure if if I answer your question, maybe you meant something else by asking for difference between these two resin. So if you can speak up, I would be happy to elaborate a little more. I'll be waiting for somebody to maybe continue this conversation. Oh, and maybe it's a question to Eric about TSA. Go ahead.
Yeah, I've seen. I would like to take over this question. So the question was, in the past, I've seen that the TSA does not necessarily correlate with the Handfeel panel when softener is used. Have you seen this? If yes, can you possibly explain why? Maybe this could be the issue. I have mentioned before that if using the TSA to correlate with the human Handfeel panel, it's very important to every time use the same testing procedure. So, for example, one issue could have been that maybe the testers have tested the materials from both sides. With the TSA, it maybe only have been measured from one side, maybe, or also maybe another algorithm to calculate the Handfeel value has been used or should be used. For example, there are algorithms for the Handfeel calculation for base tissue, but also for finished goods. And also what to consider is the surrounding temperature and humidity, not because of the TSA, but because of the tissue paper, because as you know, tissue paper is very, very sensitive to changes of temperature and humidity, and this results in different measured values. If you want, I'm very willing to maybe support you as good as I can. And if it's allowed, you can go to our MTech website. There you will find my contact details. And if you want, you can contact me directly, and I will do everything what I'm possible to do to support you with this issue. And we can go over this directly if you want.
And the next question is for buff tissue. Would it better to reduce hardwood? And it's, let's see. Somebody's moving 1 second. Let's see. Okay. For buff tissue, would it better to reduce hardwood and its high fines while using a softener, or by using dry strength resin with high hardwood and fines level to reduce the dust? Our experience is that the most effective is the use of dry strength resin, and possibly increase hardwood content while reducing refining of softwood to reduce the dust, but also to increase the softness of the tissue. Remember, the biggest effect on softness has fiber. So really high content of hardwood would impact the softness to the highest degree. So I would prefer this approach. The next one is the main mechanism of dust reduction with strength resin through increasing interfiber bonding or changing the Z-directional distribution of fines within the sheet. I would say it's through the increased fiber bonding and to reduction of fines content. Next one, what % moisture solids were sheet samples, were the hand sheet samples, and when the spray was applied? Good question. I'm not they were pretty wet. I think they were pressed on the press before they were sprayed, but they were not dried. But I don't think we measure. I know for sure we did not measure the moisture content in this hand sheets, but just by the feel, I would say that the moisture content was at least like 50%. And another, it's interfiber bonding strength, but no question really, so I'm not sure what it means. And here it's Eric for you. It's possible to have Eric emails address to follow up on other questions.
So from my side, of course, it would be possible. I could type in if this is allowed according to TABI regulations. So this is our, what you can see here, this is our general email address. So if it's allowed, I could type in my direct email address to the participant here. If it's allowed, I can do it.
Absolutely.
Okay, then let me just type in this here. It's okay.
Are there additional questions?
I see some questions on the chat. Let's see. Any case studies of using fractionation to separate the short and long fiber to use in different grades of tissue paper? Yeah, I don't have this type of case study, sorry. What is the minimum time required for softener to work? There is no time requirement. You just apply the softener, you dry the sheet. Softener, it's really not reactive chemistry. It's retained on the surface of the fiber through this mechanical means, and also through the fact that most of the softeners will have cationic charge, which allow interaction with an anionic charge on the fiber. So the effect should be immediate after drying the sheet. Anything else? Yeah, I don't see any. Okay, good morning. Can use solution polyacrylate amphoteric to all type of tissue? Yes, yes, of course. It's depend what type of amphoteric it is, and you need to, of course, measure the wet end charge to make sure that the charge of wet end would not become cationic after the application of this amphoteric resin. Okay, anything else? For towel examples, with the GPEM, in addition to the usual wet and dry strength typical used in towel. Yes, it was in addition to PAE resin, permanent wet strength resin. Yeah, I don't see any more questions.
Okay, well, let me go ahead and wrap it up. Again, thank you, Eric. Thank you, Lucina. Those are
very
great
welcome.
presentations. We will get this out. I'll work with Rob to make sure that it's timely. And again, thanks everybody for attending. And do recall that we're going to have 3 follow-up webinars. First one's going to be in April. This is going to be on using a laser to measure dust generated off a paper machine. It can also be done in converting. The next one will be reviewing Yankee coating packages and different doctor blades. And then the last one in the series will be use of enzymes to encapsulate dust as it's generated within the paper machine. Additionally, if you would like to get a continuing education credit, make sure to email Robert at the email address below, and he will get those issued to you. So again, thank you, everybody. Appreciate your attendance. Look forward to future webinars, particularly the next 3 webinars we're going to have, and we'll get information out on those on a timely fashion. Thank you again, everybody. Appreciate your time.
Yes, thank you
Thank
so
you.
much, guys, for attending. Take care and
Thank you
have a
very much
wonderful
to
day.
all.
And thank you, Dave.
No question. Thank you.
Thank you, everyone.
Great job, everybody. Great questions, great audience participation, and great timing. Fantastic work, everybody.
Yeah,
So
Look
it-
forward to the next sessions, David.
It's pretty.
Just a real quick before everybody jumps off. Let me end one thing real quick. I'll send out the update on the numbers.
Okay.
Great.
Sorry.
All right. Again, thank you, Robert and Hannah. Greatly appreciate all your help on this. We've got our upcoming ones. I need to get busy on the next one. And I'll start working on that pretty quickly because